Lesson 5, Sampling and Sampling Distributions. When we say sampling, this is the process of selecting or choosing the participants in your study, or simply the respondents of your study or a certain research. Sampling has two types. The first one is the random sampling and the second one is the non-random sampling. In other books, random sampling is also called a probability sampling. If the sampling technique that you're going to use is under random sampling or probability sampling, it only means that everybody in the population has an equal chance of being chosen as your respondents. Or in other words, every individual in your population can be chosen as your respondents. Then for non-random sampling, in other books it is also called as non-probability sampling. Non-random sampling is the opposite of random sampling, wherein if you will use a sampling technique that is under non-random sampling, not everybody in your population has an equal chance in being chosen to be your respondents. The most commonly used random sampling are simple random sampling, systematic random sampling, stratified sampling, and cluster sampling. The first random sampling that we're going to discuss is simple random sampling. When we say simple random sampling, this is the easiest sampling technique that we will use, since under this random sampling, we just use simple techniques in identifying or selecting the participants in the study. Here are some examples of techniques that you can use if you are under simple random sampling. So the first one is the lottery technique, wherein you just assign numbers and then in the name of each participants, and then you just get a random number, and then the name corresponding to that number will be selected as your participants or will be chosen as your participants. And then next technique that you can use if you're under simple random sampling is the fishbowl technique, wherein you just write the names of the individuals in your population in a small piece of paper, then you put it in a container, then you randomly select a piece of paper. The randomly selection of index cards during recitation that is done by your teachers during the face-to-face class is also an example of simple random sampling. Next is systematic random sampling, wherein from the term itself, systematic, we have a system that we should follow or system that we should use in selecting the participants. Or we will just have a pattern in selecting participants if you are under this sampling technique, wherein we will choose every nth element in the given population. So for example, you list down all the names of your population, and then you give each of them a number, and then all the numbers or all the names with a number that is a multiple of 2 will be selected as your participant. Is stratified random sampling. In stratified random sampling, we form stratas, or when we say strata, it is another term for groups. We form groups, and then for each group, you select a participant that represents that group, and then you combine it with other groups, then that will be your participant. So just like the picture in the right side, wherein you choose representatives from group 1, group 2, group 3, and group 4, and then you combine those representatives, and then that will be your participants, or that will be your sample or respondents. So each group has a representative in your sample. Just to give you a real life situation, if you are under this sampling technique, now let's say your population is the senior high school students, and we divide them into groups according to their strands. Now, let's say we have UMS, GAS, ABM, STEM, ADT, and ICT. And then if you're under stratified random sampling technique, we have to get a representative from UMS, a representative from GAS, a representative from ABM, a representative from STEM, a representative from ADT, and a representative from ICT. And then from um, and then those representatives will form your sample. So that's how stratified random sampling technique works, wherein you get a representative for each group and then you combine them to form your sample. Last is the cluster random sampling. When we say cluster random sampling, this is almost the same with stratified because we also form groups if you are under this random sampling technique. But in cluster random sampling, we choose the whole group as our sample. Now, for example, let's use the picture on the left side wherein we choose group 1 and group 4, the whole group 1 and the whole group 4 as our sample, and then we disregard group 3 and group 2. The previous example, let's say again our population is the senior high school students, and we classify them or we group them according to their strands. So if naman you are under cluster random sampling, you just, let's say we just choose two strands, and then the individuals in that strand will become your sample or the participants in your study. Now, for example, we will choose STEM and ADT only. So all the students under STEM strand and ADT students will become your sample, and then the rest of the strands will just be disregarded. Next kind of sampling is the non-random sampling technique. Under this sampling technique, we have the convenience sampling, purposive sampling, quota sampling, snowball sampling, voluntary sampling. So the first one is convenience sampling. So when we say convenience sampling, the convenience of the researcher is taken into account, wherein you will just select participants that is convenient to the researcher. So for example, his friends or classmates or their families or anyone just around them. Just make sure that if you will use this kind of sampling technique, you have a valid reason for doing so. Na, just like what we are experiencing right now, since we are still in the state of pandemic, we can use this kind of sampling technique in choosing our participants, since we have limited access for everything. Next is purposive sampling. So for purposive sampling, from the term purposive, the researcher should have or should know the purpose of his or her study. And then after identifying the purpose of his or her study, from that purpose, you have to list down the characteristics of respondents that you should have. And then from that characteristic, you will choose your respondents in your population. Now, for example, I need a female senior high school student. So, let's say your um, population is senior high school student, and then you just select female respondents only. We disregard all the male. So that's how purposive sampling works. You just have to know the criteria in choosing your respondents. Is the quota sampling. So from the term quota, we should have a quota, and then after reaching that quota, we can now stop the process of getting your or selecting your participants or selecting your respondents. As an example, let's say you need 50 male senior high school students. So given the we are in the state of pandemic, we cannot hand out survey forms. So let's say you will just post a Google form linked in your Facebook account, and you will let the respondents answer those survey forms. And then, since your quota is 50 male senior high school students, upon reaching 50 male senior high school student, you will stop the selection process. Next is snowball sampling technique. So how do this works? It works just like a literal na snowball na, 'di ba? For a snowball to become bigger in size, you have to roll it in an area where there is snow. So upon rolling it repeatedly, the snowball becomes larger and larger. So if we will relate it with the selection of participants, what we're going to do is that the researcher will just look for one participant, and that participant will look for another participant, and then that participant will also look for another participant, and the process will just goes on and on. So para siyang networking na you can gather, or you can form your sample with the referral of other participants. So when do we use this kind of sampling technique? We only use this one if the researcher has a limited access with the kind of participants that he or she should have. Na, for example, your study is about HIV patients. So if you are an HIV patient, you do not tell the world that you are an HIV patient, right? Parang it's a top secret. So if it is a top secret, how, as a researcher, how are you going to know if that participant is an HIV patient, right? So what you're going to do is just look for one HIV patient, and that HIV patient will just look for another HIV patient, and he or she will just refer it to the researcher. So that's how the selection of participants will be, na parang you can complete the, parang for example, you need 5 HIV patients, so you can gather that 5 with the referral of other participants. Lastly, voluntary sampling. If we are under this kind of sampling technique, the respondents will approach the researcher, and he or she will volunteer in taking part in the study. So, for example, your classmate is conducting a study about senior high school students, and you know for a fact that you are qualified to become his or her respondent. So, if you know na you're qualified and you are willing to answer his or her survey forms, so you will approach your classmate, and then you just tell him na, I volunteer myself in um, taking part in your study, or you can select me as your participants in your study. Next is sampling distribution. So in this part, we will not um, compute anymore, but I will just present you how are you going to compute if you're under the sampling distribution, because this is just a parang proof that the sample is a representation of a population. So we will not compute na as in like what we did in the previous lesson po. So I will just present the computation po. So for the sampling distribution, it's just like a proof that your sample is a representation of the population, even though you will get a different numerical value from the population and the sample. Na we may get, or we will definitely get a different numerical values for each sample that you will get in the population and the population itself. But when it comes to generalization, the answer will always be the same po for the population and the given sample. So let me explain sampling distributions further with the use of an example. Suppose that a population consists of 6 employees in a small business. The random variable of interest is X and is the number of years the employee has been with the business. the values of the variable as are follows. So ayun po yung table. Next, what we're going to do is, let's say we have a population as like this, and what we're going to do is we will prove that given this population, we will try to get a sample from this group, and let's see what's the difference between the numerical values with the population and the sample itself. So, for us to make the comparison between the population and the sample that we will get, so we must first get the population mean, population variance, and population standard deviation of the given data. And the formula in getting the population mean is the summation of x all over n. So what we're going to do is get the average of these numbers. In getting the average of these numbers, we'll have 1 plus 2 plus 3 plus 4 plus 5 plus 6 all over 6 since we have 6 numbers. Simplifying, we will have 3.5 as the population mean. Next is to identify the population variance and the population standard deviation. So in getting the population variance, we have the formula as the summation of the squared of the quantity of x minus the mean all over n. And then for the population standard deviation, it's just the square root of the population variance. If you can remember, we already discussed variance and standard deviation during subquarter A. But if nagtataka kayo, why is that we have a different formula for this one? It is because po, we have a different set of values wherein last subquarter, the given values are the probabilities, while in this one, the given values is just a numerical value itself, a raw numerical value. That's why there's a difference between the formulas. But anyway, we will just have the same process wherein we will construct another column for x minus mean, and then construct another column for the squared of the difference between x and the mean. And then we just get the summation of that one divided by n, then that will be the variance. Getting the summation of the last column, we will have 17.50 all over 6 since we have 6 participants. Simplifying, we will have the population variance as 2.92. Next is the population standard deviation. So all we have to do is get the square root of 2.92, and the square root of 2.92 is 1.71. So meaning the population standard deviation is 1.71. Next is we will now identify, or we will now get a sample from the given population. So for step 1, we should identify how many samples do we have to get in that given population. So let's say we are asked to get 2 samples for each or for that population. So we must identify first how many possible combinations do we have if we will just get 2 samples from that population. So we will use the formula for combination, na the combination of n taken n. You can try to solve it in your calculator. It is a function for combination, or if not, we have the formulas for combination as 6 factorial all over the quantity of 6 minus 2 factorial multiplied by 2 factorial. Simplifying everything, we will have 15. Meaning to say that if we will get 2 samples in that 6 population, we have 15 combinations of um, 15 combinations of samples. Since what we're going to do is to compare the samples and the population, so we must identify those 15 distinct samples with the size of 2. So doing that, we will have this table. So in this table, you can see that if we will get a sample of 2 from the given population, the possible combinations are 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 3, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6, 4, 5, 4, 6, and 5, 6. Next is to compute the mean for this sample, and the formula that we will use to get the mean is the summation of mean or the sample mean all over the combination of n taken n, or simply the number of observations in this given table. To solve for the sample mean, we must identify first the mean for each sample, wherein you add those two numbers and you divide it by 2 na. For example, 1 plus 2 divided by 2 is 1.5. 1 plus 3 divided by 2 is 2. 1 plus 4 divided by 2 is 2.5, and so on and so forth. And then you add everything, we will have 52.5. And then we just divide 52.5 by 15, since 15 is the number of observations, and the answer is 3.5. Our sample mean is 3.5. And if you can remember, the population mean that we got is also 3.5. So there are some cases that the population mean and the sample mean is the same. But sometimes, or rarely naman, pero there are still times that the population mean and the sample mean is not equivalent. Just like what we did with the population, we must also get the sample variance and the sample standard deviation. So, the same din yung process nila, that we will add an additional column wherein we subtract the sample mean to the population mean, and then you construct another column wherein you square the difference of sample mean and the population mean. So for us to get the sample variance, all we have to do is add the numbers in the last column and divide it by the number of observations. So we add 4 plus 2.25 plus 1 plus 0.25, and so on and so forth. Then we divide it by 15. Doing so, we will have 21.5 all over 15, and the simplest form of that one is 1.43. So our sample variance is 1.43. Then for the sample standard deviation, it's just the same. We'll just get the square root of the sample variance. So getting the square root of 1.43, we will have 1.2 as the sample standard deviation. So let's now try to observe what is the difference between the population and sampling distribution, or the sample distribution that we computed a while ago. So first, the sample distribution mean is equal to the population mean. But there are still some cases wherein we get a different sampling distribution mean compared with the population mean. But the numerical values that you will obtain is closer with each other. Next is the sample mean vary from 1.5 to 5.5, whereas the population varies from 1 to 6. So as you can see, and obviously, there is a difference between the sample mean and the population. But also, if you can notice, there is no much big difference between the sample mean, the variations between the sample mean and the population mean. So this is what I'm trying to say a while ago, that there might be a difference between the numerical values that you will obtain, but the difference between those values is not quite big. Lastly, the graphical representation for the population and the sample mean change in shape from the population to the sample, as you can see in the given figure. So what we're trying to say given this figure is that as we include a lot of samples, the graph of those samples will become, or the graph might be a representation of a normal distribution most of the time, but there are still times that the graph is not a normal distribution, or it's not a graph of a normal distribution, but most cases the graph is a normal distribution. And that leads us to the next lesson, which is the central limit theorem. In this lesson, we will not compute anymore, since the computation will just be included in the next lesson na lang po. But what we're going to do is just just discuss, or just give you an overview on what central limit theorem is. So according to the central limit theorem, the sampling distribution of the mean of a random sample drawn from any population is approximately normal for a sufficient large sample size. The larger the sample size, the more closely the sampling distribution of mean will look like a normal distribution. Ngayon, why are we aiming for a normal distribution? It is because if we have a normal distribution, we can get a mean or an average or any numerical value that is a representation of the given population. That's why you will hear some statisticians, or you will hear your research teachers that you must include large sample sizes, because if we will get a large sample size, we can have a normal distribution. And that normal distribution, if we will have a normal distribution, the sample that you will get can most probably is also the representation of the given population. So to give you an overview of the statement of central limit theorem, we have let x be a random variable with a normal distribution whose mean is mu and the standard deviation is sigma. Let x bar be the sample mean corresponding to random samples of size n taken from the x distribution. Then the following are true. Letter A, the the sample mean distribution is a normal distribution. Letter B, the mean of the sample distribution is mu, and the standard deviation of the distribution is sigma all over the square root of n.